Good afternoon, folks. Today we're going to talk about the Pythagorean theorem. Now, the Pythagorean theorem only applies to right triangles, no other triangles, not isosceles, not obtuse, not scalene, not acute. You only apply the Pythagorean theorem to a right triangle. Now, this figure shows you the different parts of the right triangle, how it's named. Over here you have a leg, referred to this side as the leg, and that's normally referred to as side B. Over here we have another leg, and that's referred to as side A. And opposite the right angle, we have the hypotenuse. Now the hypotenuse is always the longest side of any right triangle, and that's referred to side C. So the theorem goes is like this. It's a squared plus b squared equals c squared. In other words, if you square this side plus the square of this side, it's always going to be equal to the square of the longest side. So, for example, let's say we have two sides here, and we want to find the missing side. In this case, it's the hypotenuse. They gave us one leg, which is 5. The other leg is 12. So to solve this kind of problem, first thing you do, you write the formula. A squared plus b squared equals c squared. Second step, you want to substitute. Now for a, the a side is 12, so you substitute in 12 for a, which gives you 12 squared, plus. The b side is 5, so you substitute a 5 in for the b, that's 5 squared. And the c side, or the hypotenuse, we don't have that. So we just leave it as c squared. Now, using the order of operation, what we're going to do is take 12 squared, that's equal to 144, 12 times 12, plus 5 squared, that's equal to 25. 5 times 5 is 25, equals c squared. Now we're solving this for c. So first thing you want to do is add 144 plus 25. That gives you 169. So 169 is equal to c squared. But I don't want c squared, I just want c. So the opposite of the square is the square root, which is this symbol here that you see over the 169. So in order for me to isolate the c or get it by itself, I have to square root this side. Once I do that, this square root is going to eliminate the square, leaving me with a c, because they're opposites. Just like when you add and subtract, the opposites is going to cancel. Same situation here. When I take the square root of the square, it cancels, leaving me with a c. And coming over to the left side, I do the square root of 169. That gives me 13. So this missing side here, the answer would be 13. And you see it's the longest side because the hypotenuse on any right triangle is the longest side of that triangle. Let's look at another example. This is a little bit backwards, but it's the same situation. We got a is equal to 3 in this case. This is a leg. The other leg is b is equal to 4. And they want you to find the hypotenuse, this side, which is equal to c. Again, you write your formula, a squared plus b squared equals c squared. Substitute in a 3 for a, so you got 3 squared. And then you substitute in 4 for b, so you got 4 squared equals c squared. Again, you take the square of 3. 3 squared is 9, because 3 times 3 is 9. 4 squared is 16. 4 times 4 is 16. And we bring down the c squared. Now, in order to get the c by itself, I just want c. I had to square root it. That's why you see the square root, because 9 plus 16 is 25. And you see the square root here, right? Because you just want to see. The square root of 25 is 5. Okay, so c is equal to 5. So the missing sign in this case is 5. And as you can see, the hypotenuse is the longest side of your right triangle. So that's how you would do those problems involving Pythagorean theorem, finding the hypotenuse.